Myself Chandrasekhar, welcoming you all to this incredibly wonderful Sunday का फंडा सीरीज। इस सीरीज में आज हम बात करेंगे द डिफरेंस बिटवीन लेमिनार फ्लो एंड टर्बुलेंट फ्लो through the practical demonstration. How the laminar flow looks so beautiful, so awesome. So try to find it out. मेरे पास एक पाइप है which is very smooth and flow in the pipe will be laminar. ये देख सकते हैं। अगर मैं इसको अपने हाथ को हिलाऊं नहीं तो you will observe or you will feel that the fluid is static. So this is laminar flow. अगर मैं इस पे स्पून रखता हूं, let me try to put a spoon over here. Do you see? This is how laminar flow looks, so beautiful. On the other hand, the flow in a rough pipe, this is turbulent flow because there is a roughness in the pipe. So this is disorganized, random, irregular and disturbed type of flow. तो चलिए एक और डिमोन्स्ट्रेशन से डिफरेंस फाइंड आउट करते हैं बिटवीन लेमिनार एंड टर्बुलेंट. So guys, now try to observe the flow of smoke. Do you see initial part of this smoke flow is laminar and then it becomes turbulent. So let us try to find out the concept part of it, how the laminar flow is different from turbulent flow. Hello everyone. So welcome back guys. Now let us try to understand how the laminar flow is different from turbulent flow. What are the basic difference between laminar and turbulent flow? All right. So basically the flow is classified into two types. One is ideal flow, which does not exist in reality, and the another one is real flow, where the viscous force exists. In case of real flow, the shear stress tau is not zero. It means there is a relative motion between the fluid particles. Whenever there is a relative motion, there is a shear force developed. So the real flow is the actual flow which we see around us. So the real flow can be divided into two types based on the Reynold's experimental observation. So first of all, Reynold took the real fluid or the real flow and he inserted a dye into the flow. And based on the movement of the dye in the flow, he had classified the flow into three types. So if the dye filament is observed to be straight, then he called the flow to be laminar flow. And if the dye filament is observed to be wavy, then the flow is called as transitional flow. And if the dye filament appears to be diffused or broken, then the flow is called as turbulent flow. So these are the three observations which Reynold had obtained from his experiment, and based on his observation he had called the flow to be laminar, transitional and turbulent. But yes, but we cannot do the experiment every time to find out the nature of the flow. So there was a parameter defined for classifying the flow to be laminar or turbulent. The term is known as Reynold number. So the Reynold number is defined as the ratio of inertial force to the viscous force acting on the fluid. So if we write it in mathematical terms, the Reynold number is defined as rho v L by mu, or we can call it as V into L upon kinematic viscosity, where L is called as characteristic length. L is the characteristic length. And if we are talking about the internal flow, then in case of internal flow, characteristic length is the diameter of the pipe. In case of internal flow, the characteristic length will be the diameter of the pipe. All right. So when the Reynold number is very small, or we can say when the viscous force dominates, when the denominator is very large compared to the numerator, then the flow is called as laminar flow. When the Reynold number is exactly the value 2000, when the Reynold number is less than 2000, the flow is called as laminar flow. In case of laminar flow, lamina means layer. In case of laminar flow, the fluid particles travel in layers, with one layer sliding over the other. And due to this sliding of layers over one another, the viscous force dominates. That is why the Reynold number is low, and that is the reason the laminar flow is also called as viscous flow. Laminar flow is also known as viscous flow, right? And in this flow, the fluid particles are traveling along well-defined paths, which are called as streamlines. And because of the motion of the fluid particles along the streamlines, the flow is also known as streamlined flow. So laminar flow can also be termed as viscous flow because of the viscous force dominating in the flow, and it can also be called as streamlined flow because of the fluid particles actually traveling along the streamlines, well-defined paths. So this is how you can see, this is how the fluid particles are traveling in case of laminar flow. So the laminar flow can be called as organized flow, and which exists at a low fluid velocity. When the velocity of the flow is very small, we can observe the flow to be laminar. But when the velocity of the flow becomes high, when the velocity of the flow becomes high, when the velocity of the flow increases, or we can say when the Reynold number increases, or we can say when the viscous force becomes less dominating, then the flow becomes turbulent. Turbulent is disorganized flow. It can be called as disordered flow. It can be called as violent flow. It can be termed as random, irregular. When the Reynold number is greater than 4000, the internal flow is becoming the turbulent flow. And in case of turbulent flow, because of less viscous force, because of the viscous force not dominating, the fluid particles from one layer start mixing into another layer. So in case of turbulent flow, the mixing of the fluid particles from one layer into another start dominating, and because of this there is high energy loss or large momentum transfer taking place in case of turbulent flow. So the turbulent flow is disorganized and which occurs at relatively higher velocity. So this is called as turbulent flow, which exist in mostly the flows are turbulent in nature. You can see this is the pattern. The particles are not actually traveling along the streamlines. Mixing dominates. That flow is called as turbulent flow, and mostly the flows are turbulent in nature. All right. So if you open the tap, or if you allow the water to flow at a lower, relatively low velocity, then the flow of water, you can observe it to be laminar or organized. But you If you increase the speed of water flow, then it becomes violent, turbulent, disorganized, disordered fashion. Similarly, if you take a cigarette smoke or an agarbatti smoke, the initial part of the flow of agarbatti smoke is laminar, and the later part of the smoke becomes turbulent flow when the mixing start dominating. I hope this is clear. We have already seen the experiment in and now I have discussed about the mathematical expression which differentiate the laminar flow from turbulent flow. So guys, that is all from my side. Thank you very much. See you in the next such video.